Okay, so let us solve this interesting problem, the derivative of x to power x. Now, this is an interesting derivative because while it may seem familiar to some of the power functions you may have solved before, this is a little bit different. You see, we have the derivative of x to the power x. Go ahead and do that. So we have the derivative of x to the power x. So you can see that the power is also a function of x. Now you're probably used to problems of this type where you have the derivative of x to the power n, where n is, just any power like 1, 2, 3 and so on. And this is a well-known derivative. It's n times x to the power n minus 1. We drop the power and reduce the power by 1. But that does not work in this case because x is the function whose x is the variable in the function whose derivative we are finding. So let's see how we go ahead to do this. The first thing I'm going to do is to let something else to be equal to this function. So I'm going to let y to be equal to x to the power x. That's our function. Now, what do I do to get this x to come down? Because while x is still a power, I cannot do anything in as far as the derivative is concerned. So I'm going to introduce natural logarithms on both sides. So I'll have natural log of y equals the natural logarithm of x to the power x. And what happens here? Using the properties of logarithms, I'll have natural logarithm of y equals x times the natural logarithm of x. This power here, I can just bring it behind here. Okay, so there we go. Now we have x, all of it is down, it's no longer a power, and now we can find derivatives. Let's go ahead and do that. The derivative of natural log of y, that's 1 over y with respect to y. The derivative of x times natural log of x, so we'll go ahead and use product rule here. So the derivative of x is 1 with respect to x. In that case, I keep natural log of x as a constant, plus the derivative of natural log of x, that's 1 over x, assuming I've kept x as a constant. So let's see what we have now. So I'll draw a line here just to separate. Okay, let's continue. So we have, this is with respect to x, just to emphasize. All this side is with respect to x. So I'll have 1 over y with respect to y equals, so 1 times natural log of x, that's natural log of x. 1 over x times x, that's just a 1. All this is with respect to x. So I'll divide both sides by dx. So dy dx, this is 1 over y, equals natural log of x plus 1. We're almost there. Dy dx equals y times the natural log of x plus 1. Remember, y is our function x to power x, so just write this better. I'll write this as the derivative. Y is the function x to power x, but you see this is a derivative with respect to x, so we have to get rid of the y. So I substitute back y here also, that's x to power x, open brackets. Let me just begin with a 1 times natural log of x. So this is our derivative. Very interesting. Okay, so if you come across any interesting problem of a derivative, I would love to know about it. Leave it in the comment section below and I'll consider it for my next problem. Thanks for watching. See you again.